Hi everyone, my name is Homer and ito na yung part 2 ng discussion natin on directional derivatives, gradients, and tangent planes. So we have this set of exercises, and again, I recommend that you try to answer this on your own first, and then you can check and watch and proceed uh, for our solution. So number 1, let's start. So find an equation of the tangent plane and give a vector equation of the normal line to the given surface at the point Q. So for number 1, we have z is equal to square root of x squared plus y squared, and at the point 3, 4, 5. Okay, so to find the equation of the tangent plane or even the vector equation for the normal line, what we need is the gradient for the surface. Pero first, express muna natin ang equation natin as f of x of y, ano yan? F of x, y, and z will be equal to ano yan? Z minus square root of x squared plus y squared. So, note na this is equal to 0. So, kung equal to 0, this is equivalent lang din dun sa equation na we have. Ayan, di ba? So if you have this form, we can get the gradient f okay. So partial x. So ano yung partial x dito? Negative 1 over 2 square root of x squared plus y squared. And then by chain rule, 2x sa numerator. Here, similarly, this is 2y over 2 square root of x squared plus y squared. And then, sa z naman, partial z is just 1. So if we compute for the gradient at 3, 4, 5, what is the value here? Simplify natin, cancel natin yung 2's. Okay? So when x is 3 and y is 4, x squared plus y squared is equal to 9 plus 16, 25. Square root of 25 is 5. So this is negative 3/5, negative 4/5, and 1. Okay, so bakit kailangan yung gradient nitong capital F? Kasi itong gradient ni capital F, ito yung magiging ito yung vector such that perpendicular to the surface at point Q. So parang we can imagine na let's say yung surface natin ay ganyan. And nandito tayo sa point Q. Ang makukuha natin here, this is a vector gradient ng F. Okay? So, yung tangent plane, kung i-imagine yung tangent plane dito sa drawing ko, yung tangent plane niya, pwede niyang gamitin na normal vector yung gradient ng big F. And then also, yung normal line passing through Q, so parang kapag in-extend lang natin to, itong line na to, yung normal line ng surface at Q, at point Q, pwede niyang gamitin yung gradient capital F as its direction vector and then yung point Q para ma-determine yung normal line. So, given this and the point Q, kaya na nating mabigay yung equation of the tangent plane. So, equation of the tangent plane, kailangan lang yung vector, which is yung gradient F. So, this is, paano ba tayo nag-form ng equation of the plane? Negative 3/5 x minus 3 minus 4/5, okay, y minus 4. Okay, clear ba kung saan nanggaling yung values? Plus z minus 5. Diba? Yung component ng normal vector and then x minus yung x-coordinate ng point and so on. This is equal to 0. So this is the equation of the tangent plane. How about the vector equation of the normal line? So let's say R or L yung line. L of t equal to the point and then yung component minus 3/5 t, 4 minus 4/5 t, and then 5 minus t. Okay, so ayan, just from the gradient. So mukhang madali naman, ano? So let's try number 2. B pala. So this is A, so this is 1B. So we have x is equal to e to the y cosine of z. Again, let's express as a function in terms of x, y, and z equal to a constant. So let f of x, y, z be x minus e to the y cosine z. So this is equal to 0. So yun yung constant here. So compute natin yung gradient ng f. This is equal to 1. Partial y is negative e to the y cosine z. Constant yung cosine z, pero derivative ng e to the y is itself. About sa partial z, constant yung e to the y, derivative ng cosine is sine. Okay? And evaluate at the point, anong point natin dito? E 1, 0. 1. Ang y is equal to 1, 0. Cosine 0 is 1, negative e. And then, y is 1, e. Ang sine 0 is 0. Okay, so this is gradient f. So, ayun, pwede natin makuha yung equation of the tangent plane. For the tangent plane, we have 1 times x minus e, tapos minus e times y minus 1 plus 0 times z. Okay, so this is equal to 0. Okay? And then ang vector equation of the normal line, let's say L, this is E plus T, 1 minus ET, and then 0 lang lagi sa Z. Okay? And then last sa third third dito sa first set natin. We have x raised to y, x raised to y is equal to zx. I-let na agad natin. Let f x, y, z be equal to x to the y, yung ano na lang, other side, z x squared plus xy minus x to the y. Okay? This is equal to 0. Ang gradient ng f here is equal to partial x. So, as if constant yung z, ln z, zx squared ano yan? 2x, derivative ng x squared, and then plus y minus yx, y minus 1, okay? And then partial y, this is x minus ln x, x to the y. And then partial z na makukuha natin ay itself, ay hindi pala. So, z raised to something. So, x squared times z raised to x squared minus 1. Okay, so yun yung gradient f evaluated at ano yung point natin? So, C. 1, 0, 1. So, this is equal to, note na mag-0 yung y. So, yung ln z, that's 0. Okay, ln z is 0. So, mag-0 na lang din. 0 yung first factor. 0 plus 0 minus 0. So, this is 0 lang. And then, x is 1. 1 minus ln of x. Ln of 1 is 0. So, 1 lang sa second component. And then, x squared. So, 1. And then, z is 1 raised to 1 minus 1. 0. So, 1 raised to 0 is 1. Okay? So, therefore, ang tangent plane natin ay may equation na 0 yung first, no? So, 0. So, walang x component sa y ay y minus, well, y minus 0 plus z minus 1 equal to 0. And then, ang normal line natin, normal line will be LT. So, ang point 1 plus 0t, and then 0 plus 1t, then 1 plus 1 plus t. Okay. So, yun yung manakuha natin sa A, B, and C. Let's try yung exercise number 2. So, we have a function f, x plus y, quantity squared z. Determine yung directional derivative. So, katulad ng tunong ginawa natin sa part 1 ng video. So, kailangan natin ng gradient ng small f evaluated at 1, negative 2, 1, and then yung unit vector in the direction 2, negative 1, 1. So, yung gradient muna ng f, compute natin yung partial ng x, 2 times x plus y, z. Partial ng y is the same, 2x plus y, z, and then partial ng z, x plus y squared. Evaluated at 1, negative 2, 1. So, So this is negative 1 yung x plus y. So negative 2 times 1. Okay. Same here, negative 2. Correct, no? Okay. X plus y is negative 1 squared is 1. And then, i-normalize lang natin yung vector na 2, negative 1, 1. So this is equal to square root of 4 plus 1 plus 1 is square root of 6. So u is equal to 2 over square root of 6, negative 1 over square root of 6, 1 over square root of 6. So this is, so ito na yung nakuha natin na value. So this is equal to dot product ng negative 2, negative 2, 1, dot with 2 square root of 6, negative 1 square root of 6, 1 square root of 6. So compute lang yan, negative 4 square root of 6 plus 2 square root of 6 plus square root of 6, 1 over square root of 6. So this is equal to negative 1 square root of 6 or negative square root of 6 over 6. So that's A. And for B, yung maximum possible value of du in the direction into which it occurs. So find the maximum value. Maximum value is yung gradient nga, evaluated at, I think it the same point pa rin. Find the maximum value ng du. Okay? So ang norm here ay, so yung vector negative 2, negative 2, 1. So 4 plus 4 plus 1. So this is equal to 3. So this is the maximum possible value along the direction. Anong direction? Yung vector negative 2, negative 2, 1. Okay, and then C, find an equation of the tangent plane to the surface at the point 1, negative 2, 1. So yung surface natin, yung given na yan, so let's say that is equal to 0. So yun na yung surface natin. So to get the equation of the plane tangent, so katulad nung kaninang ginagawa natin na techniques, so gradient ng f. So for the gradient ng f at the point, bakit mali yung pagka-typeset? Point dapat 1, negative 2, 1. So yun nga yung nakuha natin kanina na negative 2, negative 2, 1, ano? So ang equation ng tangent plane ay negative 2 times x minus 1 minus 2 times y plus 2 plus z minus 1. This is equal to 0. So sa third final set of exercise, number 3, let S be a surface number 3. Let S be a surface defined by the function. Yung surface natin ay defined by the function. So, ibig sabihin nasa 3D space to, ano? Kasi when you have function of two variables, x and y, yung values na nasa xy plane, meron ka makuha value for f. So, yun yung parang z natin. So, equivalently, z is equal to y squared over x. So, ganun yung idea dito sa surface. So first question, find the rate of change of f at the point P24, direction vector 1 minus 2. So directional derivative pa rin, rate of change. So directional derivative. So kunin natin ang of f. So consider natin yung nag-work lang tayo in two variables. Gradient ng f, x, y. This is partial ng x. So low d high minus high d of low, which is 1. Partial ng y. So 1 over x is a constant. 1. Okay. Evaluate at 2, 4. This is negative 16 over 2, negative 8. And then 8 over 2, 4. So yung gradient natin in the direction 1, negative 2. So i-normalize natin yung 1, negative 2. This is, ang norm niya ay 1 plus 4, that is 5. So therefore u is 1/5, negative 2/5. Okay? So therefore, using these two results and directional derivative, the rate of change of f, etc., at the direction is given by this directional derivative, f24 equal to dot product na nakuha natin. In negative 8, 4, dot with 1/5 and negative 2/5. This is equal to negative 8/5 minus 8/5, negative 16/5. B, what is the minimum rate of change of f? Minimum rate of change of f, that's just negative norm ng f at dun sa point pa rin na yun, 2, 4. This is, ano ba yung norm ng 2, 4? Square root of 64 plus 16. This is 80, square root of 80. This is negative square root of 80. Hindi ko na simplify. Minimum rate of change. Hindi naman ipinapa-specify kung which direction. Letter C, what is the vector equation of the normal line to S at Q248? So, nagdo-usapan na natin yung S as a surface. So, let's say, let this be, let as a surface tayo. So, let capital F, X, Y, Z be y squared over x minus z equal to 0. So that's the surface, that's the equation for the surface. Capital F in terms of x, y, z equal to a constant. And then kunin natin yung gradient, partial x, partial y, and then partial z. Ano yung kailangan? Normal line at 248. Okay, so evaluate this 248. Nakuha na natin yung value nito kanina, di ba? Negative 16 over 2 is negative 8. 8 over 2 is 4. And then negative 1. So therefore, ang equation for the normal line ay given by LP vector equation. So ang point natin ay 2 minus 80, 4 plus 40, and then 8 minus Okay. Ayan. So, that ends our exercises for today for our topic, directional derivatives, gradients, and tangent planes. So, thank you for listening.